It's weird, I can't hear myself. Oh, there's feedback somehow, a bit. Good, okay. Gone? Should we? Should I get started? Okay. Hello, everyone. So you have on the top of the screen the link and a QR code to go to the pad for the questions. I think you are used to that by now. This talk is going to be about scientific debugging, or debugging with a scientific mindset. My name is Alexandre Fayol. I work at Chem2Camp. I'm a solution architect for Odoo customers that we have. Don't run away. If you're a consultant or a functional person, you will still benefit from this talk, which is not going to be very technical. There's a book I read some years ago, which is called Code Complete by Steve McConnell. I highly recommend it. And in this book, Steve talks about Dante's hell. And in modern times, so in the last circle of hell, that's the place where Satan lives. But in modern times, he had to give up some of his space to make space for developers who are not debugging properly. And that's a special kind of hell where developers have to find defects by guessing or by randomly editing code and hoping that their edits will fix the issues. And of course, they have to stop when they fix the most obvious thing and live with the consequences of bad fixes and erroneous errors. Okay, and the little twist they put in that is that these developers have to assume that their code is okay and the problems come from other places, such as the compiler or the OS, or maybe a bad RAM in the computer. You don't want to be one of these developers or one of these persons. What is debugging? Debugging for me is finding the root cause of an unwanted behavior of a program. And once you've managed to find the root cause, generally fixing it is fairly easy. But you have to fix it thoroughly, okay, by fixing also the downside consequences, which include the initially reported erroneous behavior, of course. And you want also to make sure that these fixes are not going to introduce other unwanted behaviors called regressions. Okay. In this talk, we'll be focusing mostly on the first part, okay, because the second part usually involves much more specific things. Now, I said debugging with a scientific mindset. What's the scientific method? That's something that's been around for some time. Some dated back to Aristotle, okay, some dated back from the 17th century. But basically it's reasoning based on observation, formulating a hypothesis, okay, testing the hypothesis with an experiment, analyzing the output of the experiment, reporting conclusions, and possibly going back to another question. Okay. And this is what I propose doing when you have unwanted behaviors in computers. How does this apply? Well, first, you don't want to be stuck in the infernal circle that I mentioned before, so you need some method. Okay. And it happens that computers are usually quite reliable and behave consistently. What does it mean? It means that given the same set of input, they will tend to produce the same set of outputs. And even if they don't, 99 I don't know how many 9% of the time, it means that the input set was not the same. And that's a very precious hint. And that's something you are going to be able to feed in your theory and in your tests. Okay, so assume computers behave consistently, you will save time. So the approach I propose is a 7-step approach. First, gather information. 2, formulate a theory. 3, devise an experiment. 4, run the experiment. 5, iterate. Okay, and then there are 2 additional steps, which are peer reviews. You don't have to do them all the time, but having peer reviews, that's also part of the scientific mindset. And then the actual bug fixing. Okay. Now, as I'm a developer, I like to start my list at 0. So there's a step 0. And since I'm old-fashioned and close to 50 years old, I will recommend that you find something to write on. I use a sheet of paper and a pen, but it can be anything. It can be a pad, it can be a text file on your computer, whatever. A whiteboard works great also. Because the bug you're investigating, if you start having to use this method, it's probably not a trivial bug. So, and you're probably only seeing the tip of it. And the tip may fit in your head, but the whole bug won't. I guarantee that. So be ready, okay? Be prepared. And because once you're digging down, you will find not having something to write on an excuse not to write down what you're doing, and you'll see that we are going to do quite a lot of writing down things. So, step 1, gathering information. Yes, I'm also a Simpsons fan. What information do you have at hand for your debugging session? You have lots of information. So, gathering it means not forgetting any precious source of information that could exist. This includes error messages. Read the error messages. Don't be like your end users who close the error message box. Read it. There's information that your fellow developers put there. Okay, so read it. It may not be end user oriented, but you are not necessarily an end user. You're a power user at least. Okay. You have stack traces. Okay, you know this small button copies the stack trace to send it to your bug report. Okay, you want to read the stack trace. You have the instance. You can try to reproduce. You can try to figure out what the bug report means. Okay, understand where the user has clicked. Okay, you have application logs. Okay, these are precious. If you are having them in raw text files, that's good. If you are having them injected in some log stash or a power tool to search logs and use correlation, that's even better. You have Odoo's profiling tools. These were mentioned a bit earlier this morning by Nicolas Stanley. Rewatch his talk. It was super interesting if you have an opportunity. You have record metadata. Okay, you create date, write date, create UID, write UID. These are precious information also. You have chatter logs in Odoo, which will give you a history of what has happened on a given record. Okay, who did what? Because the write date gives you only the last person who wrote, but possibly other persons cancel the sale order, put it in draft again, and then change things because you see the price has changed. That's information also you need to gather. And of course, last but not least, you have the source code. But even if you can't grok the source code, all the other information, and I'm speaking to functional people here, all the rest of the information is super precious for you. Okay. And then what should you do? You should write down what you found. Things which are unexpected, things which strike you as odd, okay? Or a history, a timeline of what could have happened, okay? Start writing down. Right now, it's step 1. Okay, that's going to be the basis of what you found. Step 2 is, given all you've seen in the logs, in the history of the record that's causing the wrong behavior, okay, you have to find something which could explain what's happening. Okay? Even if you don't know, I mean, something weird happened. So if you still don't know what happens at this step, that's fine also. Okay, but you still have to start looking in the direction. And to know in which direction you're looking, you have to have a theory in mind. You do have it, okay, because you are experienced people working with Odoo. I'm sure you have it, but maybe you're not conscious of this when you're looking for information. Okay, and what this talk is about is making you aware of what you are doing when you are researching a bug. So the thing is, you write down your theory, which could be, I don't know, maybe there was too many requests on Odoo, and this caused a deadlock in the database, and this is why it took 3 hours for the sale order to be confirmed. Okay, that's a theory. Maybe it's wrong. We don't care. Okay, what can I do to prove or disprove the theory? What experiment can I devise to prove or disprove that theory? So you're going then. You have written your theory on your piece of paper or your text file. Okay, what would prove that this theory is right? Okay, where do I have to look, or what actions do I have to take to check that? So you'll also write this down. Okay, it makes sense in the end. Don't worry about that. Okay, what you plan to do? I plan to check in the logs for the right date or for an incoming HTTP request, which would, or a number of HTTP requests which could indicate that there was a deadlock, for instance. Okay, and you write down the expected output of the experiment, or what would prove or disprove your theory. Then, of course, you have to run the experiment. So you're working towards a direction, okay, and you've decided to check something. So you do check it. It could be looking at a specific request in the logs of the application. It could be running an SQL query. It could be doing some actions in the web interface to check what you want. Okay, that's actually running an experiment. And from that experiment, you'll get back some observations. Write them down. Okay, it's going to be a routine. You write everything down. And write what confirms or infirms your theory. And also, that's important, there could be some unexpected outcomes. Okay, you're running an SQL query to check, I don't know, how many incoming, how many changes were made in the database using the right UI, the right date between that hour and that hour, and you find that there's none. Okay, you were expecting maybe hundreds or thousands, but there's none. That's unexpected. Okay, and that's a new piece of information. It's going to change your view of the problem. Okay, or sometimes you run into a bug. Okay, you try to click on a button and you get another error message. That's also unexpected. Okay, you'll have to write it down too, and to make a log of all these actions and things which are unexpected, because that's a new piece of information. And you will have to decide if this new piece of information is related to the issue you're currently investigating or not. Okay, sometimes you start with one bug, you do something, and you end up with 3 other new bugs. And then you're going to iterate. Okay, did you find the root cause? If so, that's super, that's cool. Okay, check that it's really the root cause. Add one extra iteration to confirm that it is the root cause. But if not, you will have to go back, okay, refine your theory, and design a new experiment, run it until you're going to confirm that you've reached the root cause of your issue. Sometimes you'll get stuck. Okay, this happens. So what I do in this case, I have 2 strategies for that. First one is go out for a walk, or take a shower if I'm working from home, or talk with a colleague. Okay, rubber duck debugging is fine. The colleague doesn't have to know anything about the issue, not even be technically proficient in the issue. Just explaining what you're seeing can often unlock you and make your brain click, and oh, you'll have this aha moment. You know what I'm speaking of, I'm sure. Okay, but sometimes even that doesn't work. And this is where writing things down is precious, because you can rerun everything you did, explain that to your colleague without forgetting any important information, and you're going to have your peer review step here. Because sometimes a colleague will be able to tell you, okay, but this hypothesis you are making here is wrong. Okay, Odoo doesn't work like that. You said it was probably unlocked in the database, but I listened to that talk the other day in Odoo Experience 2023 about database locks, and this is wrong. Your assumption is wrong, and so this experiment doesn't prove anything. So you have to restart this step. And that's super important. And you can do that because you have your notes. Also, when you ask colleagues, okay, maybe you don't have it any more time, or you've exhausted everything you can do and you need help from someone else, okay? And you will pass the investigation to someone else. At Camp to Camp, I'm often that someone else. Okay. And this is also what I'm ranting about writing things down. Because when I don't get anything written down, what can I do? I can only restart from scratch. And losing time, precious time, redoing the same experiment as my colleague already did. And that's a waste for everyone. Okay, it still won't work because computers are reliable. I mean, if I rerun the same experiment, I will do the same thing. Okay, unless there's something wrong and I can prove it. Okay, so writing things down, this is where all the value comes from. A few power tips. Okay, when you are investigating, try to be self-conscious. Okay, if you are a very experimented developer, all these steps, the 6 steps of the iterations that I've mentioned, are things you're probably doing, but not in self-awareness. You'll be jumping straight to conclusions because you remember seeing in the data gathering a line in the logs, but you are not actually writing down. The thing is, you are not documenting your thought process. Okay, so by being self-conscious and being systematic, you'll gain efficiency for complex bugs. Obvious bugs are easy. I mean, we don't need all this stuff for easy bugs, but generally, the non-easy bugs start as easy bugs, and they evolve into weird stuff. So this helps you staying focused and not chasing too many hairs. I don't know if that's said in English. Chasing too many leads at the same time. Focus on one single lead at a time and don't try to design an experiment which proves or disproves too many hypotheses at the same time. One at a time. When investing in pair, because you can do pair programming, you can do also pair debugging, remember to explain your thoughts to the person sitting next to you. This will teach them things. This will help them taking notes, and you can delegate taking notes, and you can exchange, bounce ideas back and forth. So don't stay silent while you are investigating something. And this is also especially important if you are a developer pair debugging with a functional person. Okay, they need to understand what happens and not watch you performing magic stuff with your keyboard. Okay, bring them in, teach them, help them learn and become better at understanding the internal parts of Odoo. In your note-taking, keep a special place for things you label as unrelated issues. You'll find other issues. You'll find an error message in the logs that's been in the logs for months, happening again and again and again. Okay, I don't know, a cron which is getting restarted because it's timing out. That's not related to your issue, but it is an issue. Write it down, keep it for later. Put it out of your head. Okay, in your log filtering, remove the line, but you've written that down, so it's not required to keep it in your head while investigating the main issue. Finally, once you've succeeded fixing the bug, in the end, okay, the battle is over, you're dusty, bloody, it's been an epic fight. Explain that. Share what you've learned to your colleagues. Explain the different hypotheses. Don't only tell the end of the story. The whole story is interesting, and the whole story will bring knowledge to your colleagues and save them time when they have to investigate not the same issue, but a different issue with connections with, okay, he tested this that way when he investigated that issue 6 months ago. Okay, I need to test the same thing. I can benefit from the experiment he devised. Okay. Step 7. Okay, fixing the bug. Once you found the root cause, I generally find that this is the easy part. Okay, so I will, as we say, left this as an exercise for the reader. I cannot give advice about how to fix things in code. I mean, general advice doesn't work. But you can still use the same process. Okay, if you're not sure if something will fix the issue, devise this as an experiment. Okay, the execution of the experiment will be changing the code in such and such way. Okay, putting some logs saying, okay, I've changed that. I saw that the value was so and so before I made the change. I executed that function, and after I get the correct value, I'm super satisfied. Writing a unit test can be another kind of experiment, and that's even more precious because you'll have another unit test in your unit test base, and your code will be safer in the future. 10 minutes left. Are there any questions? If not, I have a story.
No questions.
No questions? Yes?
No question.
No question? Okay. So a story of an investigation I did using that method a few months ago was about a customer who was complaining that a sale order on his e-commerce website that he had confirmed, that had been confirmed at 4 p.m., reported as delivered at 7 p.m. by the warehouse, was only seen as shipped in Odoo at 6 a.m. on the next morning. And this had happened for 700 sale orders on a Tuesday morning, which was a bit strange at first. And then for the rest, we didn't understand when it was reported. And then on the next day, everything happened normally. So we said, okay, fine. And then the next week, on Tuesday, same issue again. So this started as something a bit strange. And I was called in and started looking at things. And what we saw was that on the, that was on Wednesday mornings. What happened was we got a huge load of sale orders being shipped on the Tuesday evening at 7 p.m. That was a daily batch sent by the warehouse company. And what happened was that there was a 7 hours delay before we got the notification that the sale order was shipped, and we got to process the thousands of sale orders that had been shipped and reported as shipped on the Tuesday evening, which was unusual. So we went to see what was happening because there was not that many sale orders processed actually or confirmed on the Tuesday. And so we kept searching in the logs what was happening. We were certain that it was a question of volume, and the queue job that was processing them was just having too much work, and it needed to process them sequentially, so we were just stuck with that. And the aha moment came when we noticed that the first Monday was the 1st of May, which is a bank holiday, public holiday in France. And then the 8th of May, the week after, is also a public holiday in France. Which means that on the Tuesday, the warehouse company had to ship the sale order confirmed on Saturday, Sunday, and Monday, and Tuesday, which was way more than the usual load we had. And on normal weeks, we got the normal workload, which was enough to process before midnight. So no special issue in the code, but a good explanation in the end. Thank you. Yes?
Someone is asking, where can we find the slides for this presentation?
You can't so far. I haven't published them. I will put them on SlideShare. Probably announce a link on Twitter or something like that. You can reach me on LinkedIn easily if you want to have a direct link right now. Or come to me at the Cam2Cam booth. I will be there this evening.
And finally,
yep.
What to do when the allocated time is really short?
For debugging, what to do when they
Write notes.
I don't have any solution for that. You could use a speech recognition system, maybe. Not sure. Don't ask ChatGPT to generate the notes for you. Okay, thank you. Thanks, everyone.